All right, so I am looking at page 17 in your 3A packet, example 4. So the directions say rewrite y equals negative x squared plus 6x minus 11 using vertex form. Now let's just recall vertex form is y equals a times x minus h squared plus k. So if I'm rewriting using vertex form, I am going to actually take this space down at the bottom and write this problem again. So I've got negative x squared plus 6x minus 11. Now, hopefully you watched the last couple videos and you remember that your first step is to look solely at these x squared plus 6x, and you're trying to think about how to complete that square. So notice I've got a negative in front of my x squared. So that's my a value, negative 1. So I'm going to factor out the negative 1, and I'm left with x squared, and this turns into minus 6x. And then again, I'm going to leave a little blank. And remember, whatever I add here, I'm actually also going to subtract so that they cancel each other out. And then this negative 11 just travels along for the ride. So I've got x squared minus 6x, and I'm thinking about what can I do to complete that square. So negative 6 divided by 2 equals negative 3. And if I square that, I have plus 9. Just keep in mind, if I add 9, I also want to subtract 9. Now I've found that magic number that completes the square, and I need to rewrite x squared minus 6x plus 9 as my perfect square trinomial. So I'm going to rewrite that. That's x minus 3 squared. So I have x minus 3 squared minus 9. All of that is in parentheses with a negative 1 out in front. And this negative 11 is still traveling. So this whole set of parentheses transformed into x minus 3 squared minus 9. Now I'm going to distribute that negative 1. So I've got negative 1 times x minus 3 squared, and this turns into positive 9. Now it's broken outside of these parentheses, and I have this negative 11 out on the outside. So in total, I've got negative 1 times x minus 3 squared. 9 minus 11 is negative 2. So here is my new equation. Y equals negative 1 times x minus 3 squared minus 2. Now I rewrote this up here so that I could use it while I'm graphing. So step 1 is to rewrite. Step 2 is to graph. So the first thing you can get out of vertex form is the vertex. So keep in mind that the vertex comes from the h comma k. So I've got negative 3 and negative 2. The inside is opposite. So that negative 3 means my x value is positive 3, and my y value is same as. So that's going to be negative 2. So my vertex is 3 comma negative 2, and that goes right in the middle of my table. Now, something you should remember from your standard form graphing is that the vertex has the same x value as your axis of symmetry. So this value of 3 is the same as the axis of symmetry, because we can remember that the vertex lies on the axis of symmetry. So I've got x equals 3 as my axis of symmetry. I can do that by recognizing the x value, or I can go straight over to my graph over here, plot 3, -2, and I can draw my axis of symmetry right. Keep in mind, I always use a dotted line. This is not actually part of the graph. It is just a reference. So now, very similarly to in the past, I'm just going to make a number line out of my x values. So I have 3, 4, 5, 2, and 1 above it. So from here, I just want to actually plug in these values and see what comes up out of this graph. So I can plug in 4 into the equation and see what happens. Now you can really use either one of these. I'm going to use the vertex form because you should be familiar with how to do it in the standard form already. So if I plug in 4, I've got -1 times 4 minus 3 squared, plugged in 4 for that x value, and then minus 2 off on the end. Now the important thing to remember is that I want to follow order of operation. So the first thing I'm doing is looking inside of these parentheses. 4 minus 3 is 1. Next thing I want to do is use exponents. A lot of you will be tempted to acknowledge this -1 first. You need to make sure you square the 1 first. So I've got y equals -1, and then 1 squared is just 1, 2. Then -1 times 1 is -1 minus 2, and I get -3. The point here is 4, -3. I can graph that, 4, -3. Now, what we should also remember from the standard form graphing is that whatever is on this side is symmetric about the axis of symmetry, so the point 2, -3 also should exist. So on the other side, you have this point as well. Notice the axis of symmetry is cutting that in half. So now I want to find out what happens at 5. So I've got y equals -1 times 5 minus 3 squared minus 2. I've plugged in 5 for the x value in the function. Order of operations says the parentheses first. So y equals -1 times 5 minus 3 is 2 squared minus 2. And I've got this 2 squared first, so I've got y equals -1 times 4 minus 2, which is -4 minus 2, which is -6. So up here I should have a -6, and up here I should have a -6. So if I plot the first one, 5, -6, goes right here. And then if I look at the axis of symmetry, it makes sense that I would have 1, -. And I'm just going to draw them. Now, as I'm doing this, I can kind of check to make sure this makes sense. One thing I notice is that it opens down. Now look at the A value. The A value is negative in both the vertex form and the standard form. That should never be different. So since the A value is negative, it makes sense that it opens down. Notice it asks me for x-intercepts, but does this ever cross the x-axis? It does not. So there are no x-intercepts. And it also asks for the y-intercept. Notice I have not gone through the y-axis yet, but if you think back to standard form, I know that the y-intercept would be -11 because of this equation. So I can do 0, -11. I also could have just plugged in 0 into this equation because the y-intercept always occurs at x equals 0. And if I had plugged in 0, I would have gotten negative 11 as well.